Okay, I'm going to try this again, guys, at home. It is about 7:45 at night. I'm really sorry, 7:50. And I'm sorry that it's taken me so long. I tried to do it this afternoon at school, and it didn't work. This is going to be for pages 17 to 21 in the cells unit, our last unit. And in the background here, you're going to see the Moodle site, and maybe you'll even hear my kids screaming in the background. Right now, you're going to see the Moodle site. I've got lots of links there for you. Please take a look at them. Onions and cheeks and about the cell history. Take a look at those. And then don't forget the little music videos. Those sometimes can be helpful. We did one that I have to show you for photosynthesis. But down here for cells, I've got one too that will go over kind of what cells are and what their job is. You can try watching that too. But what we're going to do today is pages 17 to 21. And we're going to be doing it on talking kind of about cells, and specifically we're going to look at the cell membrane, and we're going to look at how materials move in and out of the cell membrane, and so it's called movement of materials. And there are two ways that things like substances can get into or out of a cell, and one requires energy, we call it active transport, and the other one does not require energy, it's called passive transport. And we're going to talk about each of those in this PowerPoint. Active requires energy, passive does not. So let's start with the one that does not require energy. This happens normally, naturally in your body, and substances like to move from high concentrations to low concentrations. That means that they like to go from where there's a lot of them to spreading out where there's not as many. Think of perfume or hairspray. When you spray it, it kind of spreads out, and from the location where you sprayed it all the way out, and then eventually everybody can smell it. So that's passive transport, and there are three kinds. One kind is called diffusion, and that's when substances move into or out of the cell from high concentrations to low concentrations, from more to less. Sometimes, though, to get from high concentration to low concentration, if the molecule is too big to get in or out of the cell or something like that, there's a helper, a protein that can help, and that's called facilitated diffusion. To facilitate means to help something. And the third kind is the diffusion of water, and that is called osmosis. That's water movement from high concentrations to low. And again, if you just think of a piece of paper towel with a puddle of water and you put the paper towel in, it will soak up the water. Water always likes to move from where there's a lot to where there's not as much. All of these are passive forms of transport to get things in and out of the cell from high amounts to low amounts. So diffusion I already talked about. That's kind of a natural movement of something in or out of the cell. Usually that means it can fit through the cell membrane. But if it can't, if it's too big, and we need something to get into or out of the cell, then we have to figure out a way to get them through the cell membrane, and that's called facilitated diffusion. So this happens when a substance can't get through the cell membrane, or it's too big to pass, or something like that. And I'll show you what it looks like. These are some pictures, and the first thing is, again, that we're using a helper to bring things into or out of the cell from high concentration to low, so it still, again, does not require any energy. And the two kinds that we're looking at right here are, this is called a channel protein. A channel just means a tunnel, and it's big enough to let certain molecules go through. And the other kind is called a carrier protein, and in that one, it captures the substance and then kind of like closes and opens it back up on the other side. It's like carries it in. So this is for when, kind of like gates, so this is for when a substance wants to move from where there's a lot to where there's not as much, but it's too big or something and can't get through, so it uses a helper. Active transport is an energy requiring process. It's still moving substances in or out of the cell, but this time we're moving things from where there's a little bit to where there's even more. You're almost like packing things in more tightly. And that happens sometimes. Sometimes your cells have substances they need, even though there's already a lot in there, they need more. And in that case, we have three things that can help with that. One are called pumps, and then there's two other processes called exocytosis and endocytosis, and there are I'll give you some examples of those in a second here. I'll give you a second to write this down, but you're gonna get a chance to see each of these slides. So I'll pause here for 1 second and let you copy. Alright, so let's talk about the pumps first. Again, can a particle move from less concentration to higher concentration? Yes, it can, but to pack it in, you have to expend a lot of ATP, a lot of energy. And so one of the things that you can have is a pump. And each pump is made for certain substances, and it's in the cell membrane, and the ATP is then used, and it pumps the substance through. even though technically it's going against the concentration gradient. It's going from lesser to more concentration. So you can see a couple examples of sodium and potassium. This is an example where outside of the cell there's not as many sodium, inside the cell there's more, kind of thing. So what would happen if you wanted to get from these red ones in is that you would have this pump them in, or in the case of potassium, pumping in and pumping out, depending on what your body needs. But sodium and potassium have pumps, and they're really good examples. And again, this is going from low concentration to high concentration, something the cell doesn't normally want to do, so it requires energy. When you talk about also getting things from low to high concentration, if you don't have a pump, sometimes the cell membrane will pinch itself, or what we call engulf, and take things into the cell, almost like pinching into a little bubble. If it takes in a solid, then it's called phagocytosis. You can laugh later. And if it is pinching in a little bit of liquid that the cell might need, again, from low concentration to high concentration, we're packing things in. This requires energy, and this pinches in the cell membrane. So phagocytosis is solids that get pinched in, and pinocytosis is liquids that get pinched in from low to high concentration. So if you could, test yourself here, what kind is this? This would be right here is phagocytosis. You could see the cell membrane pinching in over the substance that's needed inside the cell, but again, it's from low to high concentration. And the same thing here, where you're looking at some kind of molecule being taken into the cell through this vesicular bubble. So the cell membrane actually makes like a little surrounding membrane around the substance and makes it its own little sac here. And then the body takes it, the cell takes it in. And those are, again, this is called phagocytosis, and if it's a liquid that comes in, it's called pinocytosis. And the last would be what happens if something's going from low to high concentration, so it needs energy to get it packed in more, but this time things are leaving the cell. And if that happens, then it's basically the opposite process as what we just saw. Instead of the cell pinching in and bringing something into the cell, it actually pinches around inside the cell and then brings it to the outside down here and lets it out. So it's the reverse process. So that's a way we get rid of waste, for example, if we have waste that we need to get rid of. And so when they get to the end of the cell membrane, the vesicle kind of breaks open, and as you can see down at the bottom, down here, the substance is then released out of the cell. Again, this is low to high concentration, energy requiring. And that's it. So keep looking at the Moodle, and let's see how this turned out, and I will see you all in the morning. Thanks a lot.